Okay, so hello dear. So basically, I think this is ikapila na to na parameter. Oh yeah, wow, ika-8th na. Alright, na nag-change outfit na ko para nagyudanin parameter. Actually, so yeah. So change outfit na, no? Alright, so now we'll go now to urobilinogen. Now, what is again urobilinogen? I have mentioned this already sa atong bilirubin na discussion, right? So again, urobilinogen comes from direct bilirubin, okay? Alright, so we'll review the metabolism again of bilirubin and asa makuha na, or ang urobilinogen again in a while, okay? So again, for normal urobilinogen, we describe its concentration using your Ehrlich unit. Now, Ehrlich unit is equivalent also to mg per dl. So basically, same na siya. But for urobilinogen, we use Ehrlich unit, okay? So again, the normal is about less than 1 mg per dl. Now, in reporting urobilinogen, if normal ang urobilinogen, we report it as normal and not negative. Because urobilinogen is always present in urine, and your reagent strips are not sensitive to the absence of urobilinogen, meaning ma-detect dyan na niya, okay? So, dili niya ma-detect ang absence sa urobilinogen, alright? Although it's quite significant, ang absence of urobilinogen, but again, dili siya ma-detect sa imuhang urine strips, okay? Alright, so, again, we describe its concentration as Ehrlich unit, and Ehrlich unit is also the same as mg per dl, so please take note. Now, again, we'll just revisit again the metabolism of bilirubin, right? So bilirubin comes from the heme portion of your hemoglobin, right? Your RBCs after 120 days, they are phagocytized in the RES, reticuloendothelial system, in your spleen. And so of course the hemoglobin, right? Again, hemoglobin is now divided or broken down into your heme, right? And your globin. And your globin, since these are proteins, mubalik na siya, gamitin na siya usab sa body, and your heme, dila na magikan ang bilirubin. Okay? Diba? Alright? And again, we have two types of bilirubin, right? You have your unconjugated, that's the first type. Unconjugated because again, wala pa siya na-bind sa albumin. It's also non-polar or non-water soluble. So, from bilirubin or gikan sa spleen or sa RES, the unconjugated bilirubin is presented to the liver for conjugation by the enzyme glucuronyl transferase. So glucuronyl transferase adds glucuronic acid. It will now become bilirubin diglucuronide. And that is your conjugated bilirubin or your B2. Now again, this B2 is released to the intestines, to the bile duct. Kanang mag-release ang liver og bile through digestion. And this B2 or direct bilirubin or conjugated bilirubin is now acted upon by the bacterial enzymes found in your intestine to convert it now to urobilinogen. So therefore, ang urobilinogen, guys, it's always gikan siya sa B2. And your urobilinogen, again, further broken down by bacterial enzymes to stercobilinogen, and then further oxidized pag yun to fecal urobilin and stercobilin. And I've mentioned, diba, stercobilin, the major pigment that causes your stool the normal color brown, okay? And of course, your urobilinogen can enter again the enterohepatic circulation back to the liver, and by doing so, maato na po siya sa kidneys. That's why we excrete also urobilinogen, okay? So that's the metabolism of both bilirubin and urobilinogen, okay? Now, we now go to its clinical significance. Now, as you can see, your clinical significance are mostly, again, due to the liver or sa liver na mga functions or liver diseases. And aside from that is your hemolytic disorders. Now, what do you mean by hemolytic disorders? These are type of diseases in which there are excessive or continuous lysing of RBCs, okay? May it be because of immunological processes or because of other infections, okay? So that's your hemolytic disorders. Now, why is urobilinogen important or included, or why are hemolytic disorders included in the clinical significance of urobilinogen? Now, let's see this table. Okay, so this is a summary, all right? So, first is bile duct obstruction. So, remember, diba, in your anatomy, gallbladder, na bile duct dito, padulong na sa small intestine. So, the gallbladder releases bile padulong sa small intestine through the bile duct. Now, let's say na ay bile duct obstruction in cases of mga cholecysthiasis, cholelithiasis, which is yung gallstones, right? Gallbladder stones. So, example, bile duct obstruction dito. So, what happened? So, because, again, remember that the type of bilirubin makita na gid sa ihi, if mo positive man gani mong ihi o bilirubin is always B2 because B2 is water soluble. Dili na B1 ha because B1 is water insoluble. Okay? So, ngano mo positive ang bilirubin? Because again, pag-release sa gallbladder sa bile, walay makaagi. So what happens is instead of mo adto sa intestine ang bile, mubalik ra siya sa imuhang liver and or sa circulation. And mabalik na pud siya, that's why ma-filter siya sa kidneys. Muna mo positive ang bilirubin. Understood? Now, anong normal or absent ang urobilinogen? Because again, your B2 cannot pass through the bile duct to the intestines, right? So, dili ma-convert sa bacterial enzymes ang supposed to be B2 to urobilinogen. That's why normal or absent ang urobilinogen sa ihi. Understood? In bile duct obstruction. Okay. Now, for liver damage, ngano positive ang both? Because again, positive or negative because it would depend on the extent of the damage of the liver. Now, if intense na gud kayo ang damage sa liver, so what happens is, katuyang mga na-convert na B2, because of leakages sa imuhang liver na tissues, mu-leak ra siya to the circulation. That's why ma-filter siya by the kidneys. As well as sa urobilinogen, still the same reason because again, your B2, since naagya po work ra gyapon ang liver or maka-present ra gyapon siya B2 sa intestines, maka-convert ra gyapon ng bacterial enzymes to urobilinogen. Okay? And for hemolytic disease, again, hemolytic disease. So, continuous ang lysis sa RBC. So, meaning daghan kang hemoglobin na ma-release sa system or ma-release sa imuhang body. That is why, daghang B1 ang ma-produce and the B1 are now presented to the liver, and then the liver also works tirelessly to produce the B2, right? So, daghang B2 na ma-produce. Therefore, daghang B2 ang ma-present to the intestine, alright, for the bacterial enzymes to convert to urobilinogen. That is why positive, grabe ka positive ang urobilinogen. Ngano negative ang bilirubin? Because again, your liver is working well. Wala naman po siya nag-problema. Ma-convert naman niya ang B1 to B2. So therefore, the B2 does not leak to any, blood vessels or other areas of your body. Diretso gyud siya sa intestine to be converted by your bacterial enzymes to urobilinogen. Okay? I do hope this is quite clear. I hope ma-picture out ra. Okay? Alright. Now, if dili pa jud kaayo, we have the different explanations here. Okay? So you may read again and look nganong inana ang results, nganong inani ang results in these different diseases. Okay? All right. Now we'll go now to your principle. The principle here is your Ehrlich's aldehyde reaction or azo-coupling diazo reaction. Now please take note, di ba, ang bilirubin is quite the same. Diazo reaction ang bilirubin. For this one, it's Ehrlich's aldehyde because we use the Ehrlich's reagent. So your urobilinogen or other Ehrlich's reactive substances plus PDAB, yes, P-dimethyl aminobenzaldehyde. You will encounter this reagent na pod in bacteriology. So please take note of that. PDAB, Ehrlich's reagent. In the presence of an acidic pH, muhi mo siyang red color. And this is one reaction from a specific na reagent strip. And this is another. You use a diazonium zot plus urobilinogen in the presence of an acid. Same ra gyapon ng color, red azo dye. Okay, so basically same ra siya og principle sa bilirubin na mogamit sila diazonium zot. Diazonium salt. Okay, all right. So for our reagents again, PDAB, A, and methoxybenzene diazonium tetrafluoroborate. So how do I remember this? For basta Euro PDAB and kaning methoxy basta taas. Okay. Taas. Okay, all right. All right, so that's for urobilinogen. Now, for color changes, again, light pink to dark pink and white to pink. Okay, so again, please take note, di ba, kamantay mo, iyahang reporting is again Ehrlich units. And please take note, di ba, if normal ra, muna ito ibutang sa imuhang results sa urobilinogen. Normal. Okay, if within normal ra, dili negative, dili positive, right? So it's normal. And then if magkadaghan na, kanina mga specific na mga numbers. Okay, and Ehrlich units. Alright? Okay. Now, for its interferences, you have your false positive, what we call your Ehrlich's reactive substances. So a good example there is your porphobilinogen. Okay, so you'll encounter this in your lecture, but I'll introduce it to you na, guys. Because, porphobilinogen are, again, parang a precursor, a precursor to the porpho and euro, or porphobilinogen is a precursor to heme, right? Precursor to heme. Alright, you'll know about this in your hemoglobin synthesis sa hema, but it's a precursor to heme. Now, porphobilinogen and urobilinogen and other Ehrlich reactive substances, ERS, they react in the same pod and they interact with our reagents. Okay? So muna siya maka-false positive. Now, we have this test in your AUBF section or in ClinMic known as your Watson-Schwarz differential test. So if you want to differentiate kung unsa bay nakakos sa imuhang usually urine positive is either by uro, porpho, or other early reactive substances. So what you do is you set up 2 tubes. Okay? So you set up 2 tubes. Butangan mo nag-ihi tanan. And your reagents here are butanol and chloroform. Now, when you mix these 2, so 1 tube is for butanol, 1 tube is for chloroform. So silang 2 butangan mo ihi daan. Alright? So ang layers na ma-form ana always, and how I remember it, okay? Your urine is always a versa. Okay, di ba medyo bastos? Versa siya. And then ang imuhang butanol, letter B man siya, pero dili siya bottom. Top siya, okay? Top ang butanol. And your chloroform ang bottom. Okay? That's the all layers na ma-form once you add butanol and chloroform. This is for your Watson differential. Okay. So just create 3 pairs of tubes. Again, urine is versa. Top si bottom. Top si butanol. And bottom si chloroform. Okay. Sorry naman guys. You know, maka-help dyan ang binastos na. Okay, alright. Now, for the first one, urobilinogen. Urobilinogen is extracted in both chloroform and butanol. So, meaning, ani na mga layers dapat color red. Okay? So, if you perform a Watson-Schwarz differential and inaani ang result na red sa chloroform and red sa butanol layer, then that means the substance is urobilinogen. Whereas kung porpho siya, it's not extracted in any of the butanol or chloroform layers. So, ma-maintain ang red sa imuhang urine. Okay? Ana na siya. Alright? So, red siya sa both urine layers. That's for porpho. Now, for other Ehrlich reactive substances, ma-extract lang siya sa butanol. So, sa butanol ra siya red. However, sa chloroform, wala. So, sa urine Japon siya red. Okay? Inana ang Watson-Schwarz differential test. Okay? So, if extracted in both butanol and chloroform layer, urobilinogen. Extracted only in the butanol layer, you have other Ehrlich reactive substances. Not extracted in any of the layers or butanol and chloroform, porphobilinogen. Okay, again, you'll have that in your lecture. Giuna lang nako dire, okay, since we're talking about this. Alright, so again, so maka-false positive yung Ehrlich reacting substances because again, in a way, they have the same reactions with urobilinogen. So mag-apil-apil po sila, no? Joiner, yes. So, muna mo react po siya. So, false positive, mga example of Ehrlich reactive substances. And you have your highly pigmented urine as well as other, di ba? It can contribute to the darkening of the reactions of colors. That's why mu positive siya. Alright? And for false negative, old specimens, because again, your urobilinogen, if not properly preserved, in the presence of light or after long periods of time, it will now become urobilin, which is a different substance, okay? And urobilin is not the one detected by the test. It's urobilinogen man. So that's why I'm a false negative, okay? And preservation in formalin, okay? And high nitrite as well. Ang high nitrite daw mo compete siya with a diazonium salt. Diazonium salt. So therefore, dili na mo react ang urobilinogen, mo na ma-false negative. Okay? Alright. Okay, so that's for urobilinogen.